Just another minute, we will begin. I'm here. Okay, good morning. We'll start. So yesterday I was uh, discussing about the sway type of frames. Okay, so I taken one frame with the sway. So we'll just continue with that example. So there was some correction in the load. Okay, and fine. This was the frame what we had taken. Okay, so I told you the fixed end moments. Okay, they have been calculated. So for this 22.5 kilonewton per meter UDL intensity, you'll come across the fixed end moments of minus 30 and plus 30 on this member BC. Okay, so that is about the fixed end moment that has been corrected. Now, slope deflection equations we have written. Okay, so what you need to consider is the sway factor here. So this unknown delta displacement, horizontal displacement of that joints BC, that will be delta. So that has to be determined in the sway analysis. Okay, so when we write the slope deflection equation, what we are getting is three unknowns. Okay, here you have theta B, theta C, and delta, this horizontal displacement, as your unknowns. Okay, so when you write the equations, what we come across is totally 6 slope deflection equations which involve 3 unknowns. Okay, and then with help of these condition of equilibrium, okay, at the joints B and C, we have the conditions of equilibrium specified over here. So summation of moments about joint B should be 0, that is MBA plus MBC should come out to 0. Okay, so when I substitute for these two equations, MBA and MBC, I'll get another equation in terms of theta B, theta C, and delta. Okay, so this is what you have. That equation of condition, the condition of equilibrium gives us this particular equation, that is equation number 7. Okay, so I used the equation of MBA and MBC in this condition of equilibrium. So it is giving me 11 EI by 3 theta B plus EI by 2 into theta C minus 4 by 3 EI delta is equal to 0. The first condition of equilibrium, that is summation of moment equal to 0 about joint B, is giving me this equation, equation number 7. Okay, now same, what we'll do is we'll again apply the condition of equilibrium at this joint C. Okay, here. So here what should happen? MCB, the moment MCB plus the moment MCD at this joint C, when you add them, it should result 0. Okay, that is the second condition of equilibrium. Same we have done at B. Now, taking that condition, what you have here? So M summation of moment about joint C is equal to 0. MCB plus MCD is equal to 0. Okay, so I have these equations of MCB and MCD in my slope deflection equations. So from where I have taken these two equations is from slope deflection equations. The 6 equations which were written for slope deflection for each of the members. From there, I have used these equations. So MCB is 30 plus EI by 2 into theta B plus EI into theta C. And MCD is 3 EI theta C minus 9 by 4 EI delta. Okay, I have added these together and equated them to 0. That is what the condition of equilibrium says. So when you do that, what we get? We are going to get this equation 30 plus EI by 2 theta B plus 4 EI into theta C minus 9 by 4 EI delta is equal to 0. Okay, let us say this is our equation number 8. Still we have 3 unknowns in this. Okay, so 2 equations we obtain from condition of equilibrium, but we are not able to solve these two because of the excess unknowns, theta B, theta C, and delta. 3 unknowns are there in these 2 equations. So 3 unknowns, 2 equations are not sufficient. So what we did was we took help of the shear conditions. Okay, in these 2 columns, AB and CD, we applied the condition of shear. What does shear condition says? So summation of horizontal forces should be 0. Okay, that is what the shear condition says. Okay, so here what we have is summation of these two reactions, HA plus HD, should be same as the externally applied force over here. Okay, so here condition of shear. Okay, shear condition says that summation HA plus HD, HA plus HD, these two HA plus HD should be equal to 80 kilonewton. Okay, or else you can also look at as 80 minus HA minus HD should come out to 0. Summation, when you add all the forces in horizontal direction, okay, it should be equal to 0. So 80 towards right minus HA minus HD, which are towards left, should be equal to 0. Or that can be modified and written in this form. HA plus HD is equal to 80 kilonewtons. Okay, now I obtain HA and HD. I'll consider each column separately, AB and CD separately, and I'll again apply the condition of equilibrium over there. What is that condition of equilibrium I'm going to use here is summation of moment about joint B is equal to 0. Okay, if I take that, it will tell me what is HA. It will give me an equation for HA here. Okay, so that is what it is done over here. So what I have taken is all the moments about joint B are considered, they are added and equated to 0. Summation of moments about this joint B over here, about this joint is equal to 0. So what are the moments coming at this joint, about this joint? So HA will have a moment about this joint, HA into this perpendicular distance, HA into 3 meters. It is in clockwise direction. So plus HA into 3. Okay, that is one moment. Then there is a couple MAB. Okay, this is a moment at joint A, which is assumed to be in clockwise direction. Okay, I assumed all moments at joints as clockwise. So That is one more moment that is there about joint B plus MEB. Okay, and directly at joint B you have MBA, so that has been added MBA, and there is a force of 80 kilonewton. A concentrated load of 80 kilonewton is applied at the center of this AB. So that will be 80 into 1.5, 80 into this perpendicular distance 1.5. What is the direction here? It is having an anti-clockwise direction. Okay, this 80 kilonewton force is having an anti-clockwise movement about joint P. So minus 80 into 1.5. So when you add up all these movements which are about joint B, it should come out to 0. Okay. Now, when I use this MEB and MBA, the equations which we have written earlier, equation number 1 and equation number 2 will give you MEB and MBA. So when I substitute for them and rearrange these terms, I'll be getting a equation for HA. Okay. So what I have is minus 1 by 3 into this is MEB. Okay, I have taken all these terms towards right. So minus into 1 by 3 into MEB plus MBA in minus this 80 into 1.5, which comes out as 120. So MEB is minus 30 plus 4EI by 3 into theta B minus 4EI by 3 into delta. This entire equation is for MEB here. Now same MBA I have taken from equation number 2. I'll give you this, you can refer that later. So equation number 2, it is giving me MBA. So it is 30 plus 8EI by 3 into theta B minus 4EI by 3 into delta, MEB and MBA. And this 120 is coming due to this 80 into 1.5. Okay, this is that 120 moment due to this 80 kilonewton force. So altogether, when you simplify this, this is what the equation for HA is. HA will be equal to 40 minus 4 by 3 I theta B plus 8 by 9 I delta. Okay, this is one equation for HA. Okay, I called it as 9, equation number 9. Okay, so we got equation for HA in terms of what? In terms of theta B and delta here, right? Okay, we'll keep it here. Now we'll move on to this next member, that is CD. Okay, here what I'll do, here I'll try to obtain an equation for HD, this horizontal reaction D at support T. Okay, I'll try to obtain an equation. So what you have to do for that, take moment of all the forces about this joint C. Okay, about the joint C, I'll be calculating what is the moment of all the forces about joint C and then add them together. That should result 0. Okay, so that should, or that is what it should happen. So here we have that equation. Summation of moment about joint C is equal to 0. Only and only this column CD is considered here. Keep that in mind. Okay, and whatever the forces are there on this column CD, what is the moment about joint C, that is done. So HD into 2 meter, HD into 2. What is the direction? Clockwise. So plus HD into 2. MCD is clockwise. So plus MCD. MDC is also clockwise, plus MDC. That should come out to 0. Okay. But actually what I want here is what is HD. I'm interested in what is HD. So I'll take all other terms towards right and I'll write equation for HD. So HD will come out to be minus 1 by 2 into 9 EI by 2 into theta C minus 18 EI by 4 into delta. Okay, this is what the equation for HD is. Further, if I simplify that, what I'll come to know is HD is equal to minus 9 EI by 4 theta C plus 18 EI by 8 delta. Okay, this is the equation for HD. Let us say this is our equation number 10. Okay, 10. Then I'll take that condition of equilibrium, shear condition actually. Okay, shear condition which we have written for the entire frame. This was the shear condition here for the entire frame. What it says, HA plus HD should be equal to 80. Okay, so now you will take this equation and substitute for our HA and HD. Okay, we have the equation for HA and HD. So those equations will be used in this shear condition. So when I do that, this is HA, this is HD, which we have written in equation 9 and 10. Okay, I'll use those equations here in the shear condition. Okay, so HA 40 minus 4 by 3I theta B plus 8 by 9ai delta HA plus HD is what? Minus 9ai by 4 theta C plus 18 by 8ai delta HA plus HD should be equal to 80. Okay, that is what I have done here. So when you add these all the terms, open the bracket, add these terms, it will give you this equation number 11. Okay, what is this? Minus 4 by 3i theta b minus 9 by 4ei theta c plus the sum will come out to be 113 over 36 ei delta is equal to 40. Okay, this is one more equation. So this is the 11th equation what we have, and it is in terms of theta b, theta c, theta and delta, three unknowns. So now what we have is three unknowns and three equations. So I can solve them. Okay, you can use your calculators. You have an option for solving three simultaneous equations in that. So when I solve that three simultaneous equation, which three simultaneous equation? 7, 8 and 11. Okay, 7, 8 we got them by uh, condition of equilibrium, summation mb equals 0 and summation mc equals 0. 11 was obtained from the shear condition, ha plus hd is equal to 80. So when I consider them and solve them, the values of theta b, theta c and delta are here, unknown displacements. Okay, theta b is coming out to be minus 0.46 over ei, rotation in anti-clockwise direction. Negative sign indicates it is in anti-clockwise direction. Theta c, the rotation is 10.33 over ei. Okay, and also it is in anti-clockwise direction. And delta, you can see it is minus 5.14 over ei. Okay, so minus indicates the sway is actually towards left. We have assumed the sway was taking place in right side. Okay, this was the direction of sway what we have assumed. Okay, but here what we are getting is delta as negative for that, indicating it is in the opposite direction of what we have assumed. So that is the sway value, minus 4.14 over ei. Now when you substitute these three displacements, theta b, theta c and delta in equation 1 to 6, equation 1 to 6 were for MAB, MBA, MBC, MCB, MCD and MDC. When you use these values, okay, earlier they were unknowns, now we have got these values of theta b, theta c and delta. So when you use them in that equation 1 to 6, you'll come to know what are the moments at the joints A, B, C and D. So I'm getting MAB as minus 23.76 kilonewton meter, MBA as 35.63 kilonewton meter, and MBC as minus 35.62 kilonewton meter. So when you add these two, it should result in 0. MBA plus MBC, it is coming out to be almost 0. Okay. Similarly, MCB 19.44 kilonewton meter, MCD minus 19.42 kilonewton meter. So this is also resulting 0. At any joint, summation of moment is coming out to be 0 at joint B and C mainly. Here there are support. So at D, you have MDC equal to minus 3.93 kilonewton meter. So this is how we get the moments after analysis in the sway, in a frame which are having sway here. So you need to take help of shear conditions. Okay, from shear conditions we'll get the additional equation which will help us to solve the slope deflection equations and obtain the unknown displacements as well as the movements in the frame. Okay, so that is how the sway analysis works. Is that clear?
Yes, sir.
So yesterday there was a slight mistake in my calculation due to this load value. So I have corrected that one. And one more correction was that HA plus HD should be equal to 80, this force. Okay, it is not 0, it is 80 because there is a force which is applied horizontally on this frame. Okay, so please keep in mind the shear conditions what we apply is for the entire frame. We are considering entire frame. Reaction at A plus reaction at D should be equal to applied horizontal force. Okay, that's one. And we took one more condition over here. Okay, summation fx equal to 0. When we dealt with the two columns separately, summation fx equal to 0 or summation mb, what we have used here, okay, to obtain the value of equation for HA and HD, it is for individual column. When you are obtaining equation for this HA or HD, you are considering the single column, only the single column. Whereas this shear condition equation is for the entire frame. Here we have considered the entire frame. Okay, so keep that in mind. Just be careful when you are working with that part. Is there any other difficulty in that? Now this is the bending moment diagram. With the help of the moments what have been calculated, the values have been used, and the bending moment diagram has been plotted here. Okay. Again, I am just checking the direction of movement. So if it is trying to bend the column towards left, I have taken the ordinate towards left. If it is trying to bend it towards right, I have taken the ordinate towards right. Like that, I have plotted this bending moment diagram. Okay. Any other discussions? Any doubts? Please ask. Okay, one more sway frame I worked out here. So in this case, okay, the sway, will it sway or no? That has to be confirmed. Okay, so again, just go with the conditions that are trying to cause the sway. Check one by one. If they exist, then sway will occur. So here I am finding that there is a two columns are of unequal height, AB and CD. They are of unequal height. So sway will occur in this frame. Okay. So first, as a first step, fixed end moments are calculated here. Okay. And degree of kinematic tendency, it is 3. Rotation at B, rotation at C, and one more is horizontal displacement or the sway in the frame. So these are the 3 unknown displacements that will be there. And what we have, fixed end moment will exist in this member BC at joint B and C. For AB and CD, 0. There is no load given to these members. So MFAB, MFBA, MFCD, and MFDC will be 0. Whereas MFBC is minus 80 kilonewton meter and MFCB is 80 kilonewton meter. These are the fixed end moment. Okay. Now I assumed that the frame is going to sway towards left. Here, I don't have any force applied in horizontal direction. Okay. If at all, if any force is given, so what I'll do is I'll just go with the direction of that force and assume that sway will be in that direction. Okay. In case it is not wrong if you assume in any other direction also, you'll come to know at the end based on sign of delta. If it is positive, it is in your assumed direction. If it is negative, it will be in the opposite direction. Okay. So here what I have done is I assume that the frame will sway like this towards left. This is the sway delta. Okay. So that is how the frame sway will sway. That is the assumption. With that assumption, I'm beginning with this problem. Okay. And now the slope deflection, when I write it for AB member, so it will be MAB, which is equal to MFAB plus 2EI by L into 2 times theta A plus theta B minus 3 delta by L. Okay. So here what I have is A is fixed. It is having a fixed support over here at joint A. So theta A will remain 0. And then what we get is MAB is equal to 2EI by 5 into theta B plus 6EI by 25 into delta. That is the first condition equation of slope deflection. Okay, for member AB. And now I'll go to joint B. Here I'll write the equation, slope deflection equation for member BA from joint B. So what that gives me is MBA. Okay, so fixed end moment is 0. Okay, 2 EI by L, which is 5 meters. 2 EI by this 5 meter. Okay, 2 EI by 5 into theta A plus 2 times theta B plus 3 delta upon L, 5 meters. So this will give MBA is equal to 4 EI by 5 plus 6 EI by 25 into delta. This is second equation of slope deflection. Similarly, when I consider member BC, what I have is MBC. It is coming out to be minus 80 plus EI into theta B plus EI by 2 into theta C. Okay, when I write the slope deflection equation for member BC, this is what I am getting here. And when I move to joint C in member BC, the slope deflection will be MCB equal to MFCB plus 2EI by L into theta B plus 2 times theta C minus 3 delta by L. Okay. So in this member BC, delta is 0. whereas theta B and theta C will exist. Okay, so after substituting the value of fixed end moment, MCB will come out to be this AT plus EI by 2 theta B plus EI into theta C. Okay, so these are the slope deflection equation for member BC. Same is done for what? This member CD. So MCD will be MFCD plus 2EI by L into 2 times theta C plus theta D minus 3 delta upon L. So here what I have at D, it is a fixed support. So again, theta D will be remaining 0. So theta D has been taken as 0 due to that fixed support. And also MFCD, on the member CD, there is no load. So MFCD is 0. Also MFDC is 0. That we have noted earlier. So what it comes out? MCD will be equal to 4EI by 3 theta C plus 2EI by 3 delta. Okay, this is Y equation for MCD. Similarly, when I write the slope deflection equation for MDC, it will be 2EI by 3 into theta C plus 2EI by 3 into delta. Okay, so verify them. Try writing the slope deflection equations and verify them. Okay, so in AB and DC, in member AB and DC, delta will be there, delta are there, whereas in member BC, delta will not be present in this horizontal member, in this B. Okay, the sway will not affect this B. Only the columns will be affected by sway. So we'll come across these delta values for the columns only. Delta is here and here. In member AB, delta, you'll find delta. In member BA, you'll find delta. Whereas in BC, you'll not come across any delta. Okay, this way, this horizontal member BC. Similarly, CB, you'll not find any value of delta. So sway, what it will do is, it will come only in these vertical members, in the columns. That is where you'll find that sway. Okay, and what I have done here is, what is the direction of delta? Okay, what should be a sign for delta? Okay, that has been taken care here. So it is slightly different than the earlier problem. Earlier, what we have assumed is, we have assumed the sway towards right. Okay, and we have chosen the sign for delta there. How we have chosen? We have taken the rotation of the member, okay, with respect to its original position. So here, if I take this member AB, it is vertical. Originally, it is vertical. Now, due to the sway, we have assumed the sway towards left. So when that sway occurs, what is the rotation here? This member AB is being rotated in anti-clockwise direction. Okay, anti-clockwise direction about joint A. So delta is taken negative. So when I substitute that, minus 3E into minus delta upon 5. So it is coming out to be this plus 3EI delta by 5. Okay, so that's why this sign is changing over here for delta. So it all depends on how is the direction of rotation of your member about the joint. Okay, so here it is in anti-clockwise direction. In that case, delta is taken negative. So here minus delta has been used. Minus into minus, it is coming out to be plus 3 delta upon 5. Okay, or plus 6 EI delta by 25. That's why this sign is changing in this case. Again, when I come to joint B, okay, what is the direction of rotation? This is rotated in anti-clockwise direction here. Okay, if we can make out the direction of rotation, so that will be anti-clockwise. From this is the original position, this vertical position is the original position of this member AB. Now after sway, this is the direction of rotation. Okay, so what is the direction here? It is in anti-clockwise direction. Even about joint B, the member BA is being rotated in anti-clockwise direction. Okay, for that purpose, what I'll do is, I'll again choose this delta to be negative. So in MBA, what I will do is, MBA, which is equal to 2EI by 5 into theta A plus 2 times theta B minus 3 delta upon L. Okay, minus 3 delta upon L. There I'll use minus 3 into minus delta upon L. Okay, so this is coming out to be minus that sign. It is coming out to be positive in this case. Minus 3 into minus delta by 5. So it comes out to be plus 3 delta upon 5 from that. Okay, that's why this sign has changed. Even you can look at this member CD. Okay, so here we have CD. please stop me and ask if you are having doubt in that part. Okay, so MCD, I've written the equation for MCD, MFCD plus 2 EI by L into 2 times theta C plus theta D minus 3 delta upon L. This is my slope deflection equation for member CD. Okay, now what should be the sign for delta? Here, you look at this. This is our member CD. When you are at joint C, okay, with respect to original vertical position of the member, this is rotated in anti-clockwise direction. The rotation here is anti-clockwise. Okay, so this delta is considered negative. Minus 3 into minus delta upon this length 3 meter. So it is coming out to be plus 3 into delta upon 3. Okay, that's why that sign is changing here. Okay, that is how you decide the sign for this delta. And similarly, MDC. So MDC here, what is done? MFDC, which is 0, plus 2 EI by L, 2 EI by 3, into theta C plus 2 times theta D, minus 3 delta upon L. It comes out to be what? Delta is substituted as minus delta here. So it comes out to be plus 3 delta upon L, plus 3 into delta by 3. So that is how the sign will be considered for our sway delta. Okay, so that is the equation of slope deflection. That is what you get here. Okay, just make sure that this is clear. That's why I have taken one of the direction towards left in this, so that you will be clear with both the sign convention, when delta is positive, when delta is negative. Just make this thing clear in your mind. And if you have any doubt, please come, unmute yourself and come in. Is that fine? Shall we move ahead? Are you able to hear me or no?
Yes, sir.
Okay, so that is the sign, what care you have to take while considering the sign for this delta. Okay, so these are the two examples. In both the examples, I have taken delta sway towards left and right, so that sign convention, assigning the sign for delta would be clear to you. Okay, so after doing that, what you are going to do is again take the condition of equilibrium. So one condition of equilibrium I'll apply at joint B, which tells me MBA plus MBC is equal to 0. Okay, so I'll take this MBA, it is here. So MBA is 4 EI by 5 plus 6 EI by 25 into delta. 4 EI by 5 plus 6 EI by 25 into delta. This is MBA plus MBC here from the third slope deflection equation. Minus 80 plus EI into theta B plus EI by 2 into theta C. So plus MBC, which is minus 80 plus EI into theta B plus EI by 2 into theta C. So when you add this, it should be 0. Or you can simplify it over here. So 9 EI by 5 into theta B plus EI by 2 into theta C plus 6 EI by 25 into delta is equal to 80. On rearranging, you will get this equation number 7. Okay. Then one more condition of equilibrium, what you can apply is at joint C. So what should happen over there? MCB plus MCD. These two moments when added at joint C, it should result in 0. So where I have MCB here, MCB is 80 plus 2 EI by 4 into, 80 plus EI by 2 theta B plus EI into theta C. 80 plus EI by 2 theta B plus EI into theta C, MCB plus MCD, which is here. What I have? 4 EI by 3 theta C, okay, plus 2 EI by 3 delta. So that has been taken here. On simplifying, this condition of equilibrium will give us one more equation, equation number 8, which is in terms of theta B, theta C, and delta. Okay. Now, to solve these two equations, there are three unknowns. So what I'll do is I'll go and apply the shear condition. Okay. So this is the shear condition what we have. So I have made use of this shear condition. So what should happen in that frame? HA plus HD should be equal to any horizontal force which are applied on the frame. So if you look at this frame there are no horizontal forces which are being applied on this frame. Only vertically downward force in the form of UDL is present on member BC. No horizontal forces are present. Anywhere on the frame, there are no horizontal forces applied over there. So HA plus HD, reaction at A plus reaction at D, when you add them together, it should result in 0. It should be 0. So for that, what you have to do first is you should obtain what is HA and what is HD. Then this shear condition equation will be useful to us. So I'll obtain HA by considering the column AB, member AB here. Okay, so what are the forces on member AB? I have shown here. This is the free body diagram for that member AB. At the base, you have this reaction HA. At support A, the reaction HA will be present. In addition to that, MAB, the moment at joint A will be there, MAB. That is taken in clockwise direction, MAB. And at B, what is there? MBA, the joint movement MBA is there. It is also assumed in clockwise direction. So considering this free body diagram of AB, I'll be able to write what is HA. I'll take moment about this joint B. So HA into this total length. What is that? 5 meters. So HA into 5. It will be having a clockwise movement about B. Okay, plus HA into 5 plus MAB, which is clockwise, plus MBA, which is also clockwise, should come out to 0. Or I can obtain what is HA here, like this. So HA will be equal to minus 6 EI by 25 into theta B, minus 6 EI by 125 into delta. Okay, so that is one equation, what I have here. I call it as A. Now, same I'll do with column CD. Okay, I'll take the free body diagram of CD. I'll show all the forces which are acting on this member CD. So at the base, at joint B, it is supported, it is fixed support. So HD is there. I've shown this reaction, HD. Okay, any direction you assume it. Okay, either keep them towards the left or right, both of them. So HA and HD, I assume them towards left. So here what will happen? HD into this distance, 3 meters. And this movement is also clockwise. So plus HD into 3 plus MDC, movement at joint D, okay, plus MCD, movement at joint C. When you add all these movement, okay, taking moment about joint C, summation of moment about joint C equals 0, I'll get this equation, okay. So this will tell us what is HD equal to. So this is what I come across. HD will be equal to minus 2 by 3i theta C minus 4 by 9i delta. So I call this as B. So I'll use this A and B equations in my shear condition, HA plus HD equal to 0. I'll use them here. So on doing that, what I'll get is this over here, the equation number 9. When you add them, these two equations, A and B, and equate to 0, that is the shear condition. So this is what you'll get, 6 EI by 25 theta B plus 2 EI by 3 theta C plus 554 or 1125 EI delta is equal to 0. This is my ninth equation. Okay, what I'll do is I'll solve equation number 7, 8, and 9 here. Okay, equation 7, 8 are the equations which we obtained from condition of equilibrium 7 and 8. Okay, which were having three unknowns, theta B, theta C, and delta, theta B, theta C, and delta. And in equation 9 also we have three unknowns, theta B, theta C, and delta. So these are three simultaneous equations with three unknowns. On solving them, this is what the value of theta B, theta C, and delta are. Theta B is 54.03 over EI, theta C minus 62.52 over EI, delta is 58.31 over EI. Okay, so where these will be used, these values of rotation and sway will be used in the slope deflection equation 1 to 6, and that will give you what are the moment values, MAB, MBA, MBC, MCB, MCD, and MDC. Okay, so these are moment values what I'll obtain. Using this, I'll be drawing the bending moment diagram. So at joint B, BA plus BC, it is coming out 0. At joint C, CB plus CD should be 0. That is the check what I'll be having. Okay. So bending diagram, I have not drawn it for this case. Okay. So try drawing for the bending diagram for this one. Okay. Is that fine? If you have anything doubts, you can ask. Please post your USN and division in this chat box, huh, for your attendance, class attendance. Okay, so I'll give these 4 frames to you for solving. Okay, these are your 4 frames what you have to practice. First, check which are the sway frame, which are the non-sway frame, and try solving that accordingly. I'll provide this. I'll share this PPT in your group. So this four problems will be available to you. This is one problem, 2, 3, and 4. Okay.
Okay, sir.
Try to solve them. If you come across any difficulty, any doubts, you can contact me, you can chat on the group, or you can also clear them in your next class. So sway frames additional step will come out there, and sign convention will be there for delta, the sway when you come across sway. Keep that in mind. With that, you proceed with the solution of the problem. So this will be the first module, slope deflection equation, slope deflection method of analysis of indeterminate structures. You analyzed beams, okay, beams with constant EI, beams with varying EI, beams with support settlement, beams with overhang portion, and frames, rigid jointed frames without sway, non-sway frames, and sway frames. These are the problems what you have dealt in this first module. Okay, those who have posted the USN, they can exit. Basu Naikwadi, Chetan Rathod, Karishma Ubbali, Manohar Moite, Hassan Sheikh Hassan, Spurtika, 19 CV 444, 18 CV 34, 18 CV 39, 18 CV 48, 18 CV 69, 18 CV 80, 18 CV 81, 19 CV 424, 19 CV 429, 19 CV 447, 18 CV 23. I think you are not with your mobile. It is connected, but you are not there.